Welcome to today's GATE session. I am Alex Prabhu, Assistant Professor, Department of EEE. Today we are going to discuss synchronous machines under the section Electrical Machines. Introduction to synchronous machine. Synchronous machine is a constant speed machine. The synchronous speed will be given here. Ns is equal to 120F by P. The synchronous machine having major two classification. One is alternators, it is nothing but AC generator. The another one is synchronous motor. The both category again sub-classified into two categories based on its rotor structure. Cylindrical rotor type, another one is salient pole rotor type. The construction overview. There are two major parts, stator and rotor. The static device known as stator. The stator having, the figure is shown in here, the stator, it is made up of high grade silicon steel laminated core. The stator having a number of stator slots. The stator slots carrying armature binding. Then that armature winding which will be supplied with three-phase supply. The three-phase AC supply, if you are giving to that armature winding, that rotating RMF will be induced here. Then rotor structure. The rotor carries field winding. The field winding is excited by DC supply with the external DC source. There are two types of rotor. One is salient pole, that is projected pole rotor. Another one is smooth cylindrical, that is non-salient pole rotor type. So next we are going to discuss two different categories, salient pole synchronous machine and non-salient pole synchronous machine. Salient pole synchronous machine, its rotor structure, okay, it is having projected pole structure. That rotor poles are mounted with its rotor shaft. Due to this projected pole structure, uneven air gap, that is non-uniform air gap will be occur in between stator and rotor. Then the winding which will be placed on that all the rotor poles and connected in series and excited with DC supply with the external DC source. Then this type of rotor having large diameter and less axial length. Due to this construction, it is suitable for low and medium speed machines. That speed it is from 120 to 400 RPM. So due to this low speed rotor, it is used in hydroelectric and diesel engine driven synchronous machines, and it is having very high starting torque. Next type is cylindrical rotor synchronous machine. Its rotor structure is made up of a single solid rotor and it is having slots. That rotor winding embedded on the n number of solid slots. That winding will be excited by DC source by external DC supply. And due to this smooth cylindrical structure, the air gap in between stator and rotor will be uniform. Then that it is having less, that is small dia and long axial length. Due to this construction, it is used in very high speed machines like 1500 RPM to 3000 RPM machines. For example, steam or turbo power plants it is used. Okay, then it is having very high mechanical strength. Power equations of cylindrical rotor machine. The power transferred is given here. P is equal to EV by XS into sin delta. E it is external induced EMF, then V terminal voltage, then XS synchronous reactance. delta is the load angle or tack angle. With respect to that delta value, the power transfer is going to be changed. When the delta is 90 degree, we can get maximum power. Next, power equation of salient pole machine. It is given as EV by XD sin delta plus V square by 2 1 by XQ minus 1 by XD sin 2 delta. Here XQ, XD are reactance of quadrature axis and direct axis. There are two terms. The first term defined here electromagnetic torque. The second term defined here reluctance torque. Okay, so the torque, overall torque put together is greater compared to that non-salient pole. Typical applications: salient pole rotor. Due to its low speed, it is used in hydroelectric power plants, diesel engine driven alternators, small and medium capacity generators, and variable speed operations. Then cylindrical rotor, due to its high speed it will use in thermal power plants, nuclear power stations, large power generating stations, and industrial power plants with high speed requirements. So now we will discuss some MCQ questions. The synchronous speed of 4-pole alternator operating at 50 Hz is. Here we have to calculate the synchronous speed of this machine. So we know that the formula for synchronous speed it is 120 F by P. Here number of poles is given and frequency 50 Hz is given. By calculating, we will get the answer is 1500 RPM. Then second question, a 3-phase 4-pole synchronous generator runs at 1500 RPM. What is the frequency of the generated EMF? So here they are asking frequency of the machine. So that number of poles is given, it is rotating speed is given. We can easily calculate from that same equation F is equal to Pn into Pn by 120. By applying that number of poles and speed, we can get the frequency of 50 Hz. Next question, in a salient pole synchronous machine, the direct axis and the quadrature axis reactances are related as. Actually, in that salient pole machine, both that axis reactances are equal. So not equal, so XD, the direct axis, due to that air gap, less air gap, the XD is greater than equal to XQ. The power developed in cylindrical rotor synchronous machine is given by, we have already discussed, that answer is EB divided by XS into sin delta. E is EMF, V is the rotor voltage, then XS synchronous reactance, the delta is here, load angle or torque angle. Which one of the following statements is true for a cylindrical rotor machine? In cylindrical rotor machine, that rotor surface is even and smooth, there is no air gap differences, so the XD and XQ both are same. That is the answer for this question. The next question, salient pole alternator has direct axis reactance is 0.9 ohm is given, then quadrature axis reactance is given here 0.5 ohm, and the terminal voltage V is equal to 1 per unit. Calculate the reluctance power when delta is equal to 90 degree. We can use that formula. In that, so the second term defines its salient pole alternators reluctance power. So it is given here P reluctance value is equal to 1 by 2 into 1 by XQ minus 1 by XD sin 2 lambda. Here I am using the second term alone. Okay, by using this formula, you can calculate its actual value is 0.385 per unit. So B is the correct answer. A cylindrical rotor alternator has V is equal to 400 voltage, X is equal to 10 ohm and E is equal to 500 volt. What is the load angle delta? So here we have to find out the load angle delta. The formula is given. Power formula is P is equal to EV by XS sin delta. So here they are asking delta value. EV value and XS values are given. By using that value we can calculate sin lambda is equal to 0.8. So delta is equal to 53.13 or C, that C is the correct answer. Then in next question, in a three-phase salient pole machine, the reluctance torque is maximum when delta is, so here we have to find out that delta value by use of that same formula. So the sine tool delta is equal to 1, so we get the delta value is 45 degree. B is the correct answer. So far we have discussed few of MCQ questions for GATE preparation. So we will continue with the next video. Thank you.